Okay, so let's go through two things. One, the sketch of the setup, and two, how are you going to be analyzing the data? So here's a side view of the table, and you can sort of go along with me as you draw what you saw. So here's the cart, and there's the pulley, that's just the wheel that was free to spin, and there's a string attached to the cart that went over the pulley, tied into a loop. On the other side was a mass hanging there, and then sitting inside the cart were some metal masses. So you can feel free to draw something like this. Want to get more detail, that's fine. Just make sure you're labeling all the important parts. Okay, so what was happening? Well, remember, I pulled the cart back and then the whole system accelerated this way. So what was causing that to happen? Well, there's a force of gravity acting on the hanging mass. There's also the force of gravity acting on the cart, but the normal force from the table was supporting the cart. There's also the tension in the string, but that's what we're going to eventually be calling what's called an internal force. Really, the only external force acting on the whole system was just the weight of whatever's hanging over the sides. That's what we're going to be using to calculate the external force on the whole system. This is what you're going to be using to calculate F, or the force, on your data table. It's only the weight of the hanging mass, where of course the mass has to be in kilograms. Now what about for the acceleration? Well, this should be kind of familiar, right? We started the system from rest. In the video I tell you how far the cart moves. That was the 65 centimeters. And you measure the time. Well, what comes to mind? We've done this sort of thing before back in the accelerated motion activity. This equation right here, of course, delta x equals v naught t plus half at squared, where of course v naught is 0. So the whole first term drops out. So why don't you just go ahead and rearrange this for acceleration. I'm sure you'll have no trouble getting acceleration equals 2 delta x over t squared. So this is what we're going to use to find the acceleration of the system, where of course delta x is how far the cart moved, and the time there is the average time from any of the trials.